Hi everyone, bonjour. The IB Crocodile is here. Welcome to my YouTube channel, specialized in providing supporting academic videos for both IB physics and math programs. So today I'm going to go through number 9, physics standard level paper 1, time zone 1, May 2023. So let's have a look. The input power of an electric motor is 200 watts. It is used to raise a mass of 10 kilograms at constant speed. If the efficiency of the motor is 40%, through what height will the mass be raised in 1 second? So let's remember the efficiency formula. What is efficiency? Okay, so efficiency, basically there are two formulas for efficiency. We call it eta, the Greek letter. Okay, so efficiency is what? Is the useful power out divided by the input power, or the total input power. Okay, this is one formulation, and this is basically the one that you are going to use. Okay, or you can say the efficiency is the useful energy out over the total input, or the total energy input. Okay, but since here we have power, so let's use the first one here. So we've got the efficiency here 0.4 or 40%, right? And useful power out, we don't know, but the input power here is given as 200 watts. Okay, so you can say, okay, so we can basically calculate the power out, or the output power, or the useful power out. And the input power here is 200 watts, right? So that implies that the output power is going to be 40% of 200, right? I mean, 200, right? Which is basically tells us this is the meaning of the efficiency, right? So 200 times 0.4, if you think about it, like 10% of 200 is 20. 20 times 4 is 80, so you can say just 80 watts. Okay, or you can replace 0.4 by a fraction, and you can just simplify using algebra. So anyway, so the output power here is 80 watts, right? And this output power here lasted for 1 second. Okay, so now we can actually convert power into energy, right? Because the power is the rate of energy transferred. So technically, the output power is basically the energy divided by time, right? The rate of energy transferred, or power also is the rate of doing work, or the rate of work done. But here, because since we talk about 10 kilograms, the constant speed, and we need the height, so you may think of the change in the potential energy, or the gravitational potential energy. So we can find here the output energy. So the energy out is going to be the output power multiplied by the time, which is 1 second, right? So we can say 80 multiplied by 1. So we are looking here at 80 joules. Now, the mass is raised at a constant speed, which means what? It means there is no change in kinetic energy. Okay, so there is no change in kinetic energy. So basically, the main difference here, or the main change, or the main output energy, is gravitational potential energy. So you can say, okay, so the gravitational potential energy is mgh, right? Where h is the height. Now we know the energy, which is 80 joules. So that implies that 80 joules is going to be m, which is 10 kilograms, multiplied by g. Now g is 9.81 if it was paper 2. If it's paper 1, by default, we use g as 10 meters per second squared. Okay, that's the default in paper 1 in physics IB. And then now we can solve for h, which is the height, right? So we can say, okay, so 80 is going to be 10 times 10, which is 100 multiplied by h, which means h is going to be, we can actually cancel 0 with the 0 here if you like. So you can say h is 8 over 10, which is 0.8 meters. Everything, I made sure everything in SI units, you know, the mass in kilograms, the power in watts or joules per second, the time in second. So the output here or h has to be in meters because that is everything here in SI system of units. So the answer, the final answer for question number 9 is B. Okay, so thanks for watching and have a nice day.